If you've ever looked up from a city sidewalk and felt the sky press back, this one's for you. We just crossed a threshold that quietly rewires our place in the story. More than 6,000 confirmed planets beyond the Sun. Not a record to hang on the wall, a map that suddenly got denser ink. The headline is big, the lesson underneath is bigger. Numbers only matter if they change how we see. 30 years ago, planets were rumored. Today there are census. The count didn't tick up because luck improved, it rose because our instruments did. Our methods matured, and our patience learned to speak statistics. We stopped chasing trophies and started building patterns. Patterns begin with how we find worlds. Some announce themselves by dimming a star as they transit. Others tug on starlight, leaving a wobble in the spectrum. A few bend background light like a lens. Rarer still, we block the star's glare and image the planet's faint glow directly. These aren't magic tricks. They're 5 different languages for the same question. What's out there? And together they convert hints into dossiers. Open the catalog and diversity shouts back. Hot Jupiters grazing their suns in days. Sub-Neptunes with puffy atmospheres. Super-Earths that our own system forgot to order. Worlds circling to stars. Worlds on tilted orbits. Worlds so light they're cotton candy, and others so dense they're cannonballs. After 6,000. Weird isn't weird, it's normal. That's the point. If you're asking, so what changes for me? Fair question. Here's the practical shift. We now study planets the way biologists study ecosystems. Instead of searching for one perfect Earth 2.0, we compare classes by the hundreds. Rocky worlds versus puffy ones, tight orbits versus roomy ones, quiet stars versus flaring red dwarfs. Insight comes from contrasts, not mascots. The boom didn't arrive evenly. Kepler taught us to stare at one patch of sky and wait. TESS taught us to sweep bright, nearby stars. Ground observatories learned to sip photons with absurd discipline. The result is a pipeline, not a parade. Candidates become confirmations. Confirmations become targets for follow-up. Follow-ups become the stories you and I can actually tell without hype. But a census isn't a destination. The mature question after how many is what kind, mass and radius give us density. Density hints at composition. Composition sets the stage for weather years, weather on alien worlds. The more precisely we weigh and measure, the less we are guessing and the more we're diagnosing. That brings us to the sharp end of curiosity. Atmospheres. We don't see leaves or oceans. We see fingerprints, tiny bites in starlight at exact wavelengths. Line up those bites across a rainbow spectrum and molecules sign their names. Carbon dioxide, methane, water vapor, acid. Stack the syllables and a sentence appears. Sometimes that sentence reads volcanoes, sometimes photochemistry, and one day, maybe, metabolism. We've already had practice reading those lines. In 2023, Webb found methane and carbon dioxide in the atmosphere of K2-218b and revived debate about high sea worlds, ocean planets wrapped in hydrogen. Later work cautioned against strong life claims. That's not retreat, that's calibration. Science is a bank account. Deposit carefully, withdraw rarely. Direct imaging, the dream shot, finally jumped from promise to practice this year. Webb captured a Saturn mass world around a young star. A milestone because most exoplanets are too dim and too close to their stars to photograph. It's not an Earth twin, it's a proof of concept that our glare-killing tools work at new scales. Tomorrow's targets just got a little less impossible. If you want to see where planets actually come from, aim your gaze to baby stars and their dusty cradles. Radio telescopes like ALMA have shown disks carved with rings and gap signatures of gravitational sculptors at work. The famous HL Tauri image, ISNTG, is pretty. It's a fossil snapshot of assembly lines building worlds from pebbles and pressure. Formation answers one mystery and opens 10. Why do giants migrate so close to their stars? Why do some rocky worlds keep atmospheres while neighbors go bald? Why do certain systems lock into clockwork resonances while others look like a cosmic bar fight? The boom gives us enough cases to stop telling just so stories and start testing them. Here is a frame that helps. Think of the galaxy as a planet factory with regional styles. Metal-rich stars tend to build more planets, especially giants. Small, cool stars are abundant and may host legions of rocky worlds. But their tantrum flares can strip air. The same physics plays out with different initial conditions, and the result is 1,000 dialects of planet. The habitable zone still matters, but only as a starting line. It's the orbital distance where surface water could exist given the right blanket of air. But clouds, rotation, magnetic fields, and geochemistry remix everything. Earth-sized doesn't mean Earth-like, and habitable doesn't mean inhabited. If that sounds like deflating hype, good. Reality is more interesting than a headline. So what do 6000 teach us? First, that planets are abundant, almost a default setting. Second, that variety is the rule, not the exception. Third, that life, if it exists elsewhere, will announce itself not with a selfie, but with chemistry out of balance. Our job is to catch that imbalance, and then spend years trying to explain it without invoking biology. If the biology explanation survives the beating, that's when history turns. The UK and US audiences know this rhythm: big claim, careful walk back, stronger claim later. That's how gravitational waves went from rumor to ringtone. It's how black holes became images. Exoplanets are running the same playbook. Patience, replication, independent teams, ruthless error bars. The milestone is news. The method is the news that lasts. And yes, we argue with ourselves. One team flags a methane line, another points to stellar noise, a third re-reduces the data and finds a subtler truth. That's not drama, it's quality control in public view. The confidence you want as a viewer comes from watching claims shrink, sharpen, and survive. There's a human angle here you can feel. Students who grew up with smartphone night modes now process spectra that decide grant proposals. Amateur observers spot transit candidates a pipeline missed. Image processors who started in photography now clean exoplanet frames. Space used to be now it's collaborative, iterative, and oddly domestic. The lab is your laptop. The sky is a data set. What about timelines? The next few years bring better coronagraphs, and if funded, star-shades devices that act like artificial eclipses. Roman will widen our net. The Habitable Worlds Observatory, if greenlit, aims its optics at nearby sun-like stars with the audacity to try for small, temperate planets. The path won't be linear, but the sensitivity will be. Every notch deeper means fewer excuses for ignorance. History loves clean beginnings, but science rarely offers them. The first planet around a sun-like star in 1995 felt like a starting gun. In hindsight, it was a mid-chapter turn. Kepler's photometric patience rewrote occurrence rates. Tests gave us bright targets for follow-up. Webb turned spectroscopy from hope to habit. 6000 is not a finish line. It's the moment we stop asking if the forest is real and start studying the trees. Let's ground one example. Suppose you catch a transit in a light curve, tiny dip every 12 days. Radial velocity, follow-up gives you mass. Transit depth gives you radius. The ratio gives you density. Add the transmission spectrum during the transit and you catch a whisper of the atmosphere. Stitch those together and you can tell whether this is a puffy sub-Neptune or a compact super-Earth. The difference is not academic. It reroutes your whole observing plan. Or consider a direct image. You block the star, collect the leftover glow, and still the glare fights you with diffraction and speckles. Algorithms dig the signal out like a fossil from sandstone. When the planet pops out a cold point, a drift year, not just sharing an image. You're validating a technique that will, one day, aim smaller and closer, and TWA7b won't host life. It will teach us how to find something that might. Formation physics. Quick tour. Dust grains collide and stick. Pebbles grow into planetesimals. Gravity takes over. Embryos clear lanes in the disk. Beyond the snow line, ESAs boost the mass budget, feeding cores that can capture gas and become giants. Migration, resonances, and scatterings reshape the architecture. If that sounds like urban planning, that's because it is zoning laws written in pressure, temperature, and time. Now the uncomfortable part. Many promising signals will fade under scrutiny. Star spots masquerade as planets. Instrument quirks look planetary until they don't. Teams retract. Catalogs get cleaned. This is not a weakness. It's the muscle that lets you trust the survivors. 6000 confirmed doesn't mean 6000. It means 6000 earned. There's also the ethics beat. If we ever corner a strong biosignature, who speaks, when, and how? The protocols exist, but are untested at scale. Planetary protection isn't just for Mars rovers. It's a mindset for how we announce, how we verify, and how we keep fear from outrunning fact. The best time to plan for a loud moment is while things are still quiet. For creators and teachers, the boom is a gift. You can tell true stories that feel like science fiction but cash out as literacy. What a spectrum is, why a light curve matters, how a coronagraph works. You can pull viewers from clickbait to craft showing not just the wonder but the workflow. Here's the plot twist is fun. Here's how we know is leadership. So, what's the single most useful way to see 6000? As permission. Permission to stop treating Earth as a cosmic exception and start treating it as one draw from a rich deck. Permission to ask constrained questions. Do rocky worlds around red dwarfs keep air? Do sub-Neptunes shed their envelopes near their stars? Does metallicity really set a system's fate? Every yes or no moves the needle from OAW to understanding. And if you need one image to carry out of this film, make it a split screen. On the left, ALMA rings and gaps in HL Tauri's disk. On the right, Webb's spectrum with clean molecular lines. Birth on one side, breath on the other. Between them, a simple diagram of a star, a planet, and our line of sight. That trigeometry birth, breathas, the skeleton of exoplanet science. We're not waiting for a single "this is it" headline. We're building a body of evidence that makes the it unavoidable. It will look less like fireworks and more like a tide, quiet, patient, unstoppable. The universe doesn't owe us a reveal. It rewards us for showing up with better questions and sharper tools. So here's the promise I can make without overselling. The next entry in the catalog won't feel like a revolution, but 10, 100, 1,000 entries from now, a pattern will emerge that makes old arguments sound small. The claim that planets are rare will be quaint. The claim that life requires our exact recipe will be provincial. The claim that we can't know will be lazy. And when that day comes, it won't erase our uniqueness. It will give it context. We'll look at our thin air and blue water and recognize them as one configuration among many a configuration that deserves care precisely. Because options exist elsewhere, not here. 6000 worlds teach us something intimate. Stewardship is not parochial, it's cosmic. If you've made it this far, you already know the right posture. Curious, skeptical, patient, celebrate the round number, then use it as a doorway. The map is thickening, the tools are sharper, the questions are better, and the sky, no matter how it looks from your block, has never been more talkative. Hook for your upload. 6000 planets now. What? Ask the viewer if they want the 3 takeaways that actually change how we search. Show them a transit light curve, a labeled spectrum, and a baby disk image. Promise part 2 tomorrow at 7 o'clock. Then ask them to follow if they want tactics, not just headlines. This is how we turn wonder into a weekly habit. And if you're still feeling the sky pressed back good, that pressure is meaning. It's the weight of a universe that no longer feels empty, just undiscovered. 6000 isn't a finish line. It's the sound of the door unlatching. Now, we push.